Hey everyone, welcome back to the channel. Today we're talking about three important concepts in deep learning. What are hidden layers in CNNs? What's the difference between ReLU and Sigmoid? And when should you use them? Let's make it simple and easy to understand. Let's go. So first, what are hidden layers? Imagine you're training an AI to recognize cats and dogs from pictures. The image goes into the network through the input layer, and a final answer comes out of the output layer, like, yes, this is a cat. Everything in between is called the hidden layers. This is where the real magic happens. These layers help the model look at the image, piece by piece, and understand what's in it. There are main types of hidden layers in a CNN, convolutional layers. These layers are like feature detectors. They scan the image with filters and look for things like edges, shapes, and textures. Activation layers, usually ReLU. After detecting features, the model applies ReLU to make sure only important signals go through. It helps the model learn faster and better. Pooling layers. These layers make the feature maps smaller, so the model can focus on the most important parts and work faster. Fully connected layers. At the end, all the features are flattened into one long list and passed into dense layers that make the final prediction. Now let's talk about activation functions, especially ReLU and Sigmoid. These are used inside the hidden layers to help the network decide what to pass forward. Sigmoid squashes numbers between 0 and 1. Think of it like giving a probability. 0 means definitely not. 1 means definitely yes. Example. If you're asking, is this spam? Sigmoid might say 0.9, best probably spam. 0.1, probably not spam. Advantage of Sigmoid. Great for binary classification. Gives probability-like output. Disadvantage of Sigmoid. Slows down training. Has the vanishing gradient problem, meaning it stops learning when values get too small. ReLU stands for rectified linear unit. It's super simple. Positive numbers stay the same. Negative numbers become 0. Example. Think of a game. If you score above 0, it counts. If it's negative, you get nothing. That's ReLU. Advantages of ReLU. Fast and efficient. Helps CNNs learn faster. Solves vanishing gradient issues. Disadvantages of ReLU. Sometimes neurons get stuck at 0 and stop learning. This is called the dying ReLU problem. In most CNNs for image classification, use ReLU in hidden layers. It's faster and works well. Use Sigmoid in the output layer, only if your task is binary classification, like cat versus dog. Don't use Sigmoid in the hidden layers. It makes learning slow and weak. Let's walk through a simple CNN, or Convolutional Neural Network, structure for image classification. This model could be used to identify whether a picture is of a cat or a dog. First block, input layer, conv, ReLU, pool. This is where the image enters the model. We first apply a convolutional layer, which scans the image using filters to find basic features like edges and corners. Then, we apply ReLU, which keeps only the positive values and sets the rest to 0. Finally, we use a pooling layer to reduce the size of the image while keeping the most important features. This helps speed up training and makes the model less sensitive to small changes. Second block, conv, ReLU, pool. We repeat the same process. This time, the filters learn more complex shapes like ears or eyes. Again, ReLU activates important patterns, and pooling keeps it efficient. Third block, dense layer, ReLU. Now, we take everything the model has learned so far and flatten it into a list of numbers. We pass it through a dense or fully connected layer, where the model starts making its decision. We still use ReLU to keep the learning strong and fast. Final block, output layer, Sigmoid, 0 dog, 1 cat. Here's the last step. The output layer uses a Sigmoid activation function, which gives us a number between 0 and 1. Closer to 1 means it's a cat. Closer to 0 means it's a dog. It's like giving the model a chance to say, I'm 90% sure this is a cat. And that's it. Now you understand what hidden layers do in CNNs, the difference between ReLU and Sigmoid, when to use each one for better model performance. If you found this helpful, don't forget to like the video, drop your questions in the comments, subscribe for more AI Made Simple. Thanks for watching. See you in the next one.